once again, let's look at our strategy. V0 in the x direction is a function of h. We've obtained it as a function of h. Remember, L is just some constant number, the length of the ramp that just goes along for the ride. So this just stands for a number. We don't want to have too many numbers in here. We're going to have some symbols so that at the end we can solve this for different ramp lengths. But h is the variable here, because h is how high we're lifting the end of the ramp. We lift up the end of the ramp higher and higher, h gets greater and greater. And that affects how far the ball goes, which is what we're ultimately trying to find. Similarly, V0y is a function of h. And if we put V0x, the function of h, together with the delta t that we get from this equation, now the delta t we get from this equation depends on V0y, which depends on h, so the delta t is ultimately going to depend just on h. We put those together, we get x as a function of h. Now the algebra is going to get really awful and really messy. Matter of fact, it took me several tries before I could get the algebra right. Of course, I have the excuse of age, but that doesn't quite cut it. I should have done a little better, I think. But the algebra is very complex. I wasn't surprised when I didn't get it to work out. Okay, we take the quadratic equation that I wrote down before. It said 96 equals v naught y delta t plus 490 delta t squared. We simply subtract the 96 from both sides and use the quadratic formula, and we immediately get this, because the coefficient of delta t squared is 490. That's our a. It appears down here as 2a. v0y is b. We got the minus b plus or minus the square root of b squared. And then our 4ac, a is 490, c is negative 96. That's going to be plus approximately 190,000. It's actually 188,000 something, but we'll live with this approximation here because it's a little easier to look at and to remember. Now, we get two delta t's, one for the plus and one for the minus. Which one do we use? Well, we use the one for the plus because we don't want a negative delta t. If we use the minus, we'd have a negative value here, minus the square root, which is going to be another minus, and we'd have a negative delta t. So hopefully, if we use the positive, we come out with a positive number. And we can see that we do, because if this was just the square root of v0y squared without the 190,000, we'd have negative v0y plus v0y, wouldn't we? Because the square root of v0y squared is v0y. And that would give us 0. But we've got a plus 190,000 here, which makes this a little bigger, so that this does come out greater than this one. So this is positive. Now, we recall that v0y, okay, let's look over here at what v0y was a minute ago. It's a square root of 2 times 980 times h over L. Now we can multiply 2 times 980 and get 1960. That's going to simplify things. We can put all this under the same square root, so we're going to have h times h, which is h squared. And we're going to have an L in the denominator. And I'm going to make an observation here that I've got an error right here. This should be the square root. This shouldn't be the square root. This should just be plain old h over L. Okay? So I'm going to cross out that square root there. That's a little embarrassing. I think since I wrote a square root here, I just wrote one here without thinking about it. The proportionality is h over L. No square root here. So when we substitute, or when we bring the h inside the square root, it's going to be an h squared, so we multiply that by h to get an h cubed, and we'll still have an L out squared. Now, an L outside here. Without the square root sign there, anyhow, we can simplify v0y to get 1960 h cubed over L. Now we take these values for v0y and plug them in where v0y occurs in the expression for delta t, and we get this expression. Okay, not the simplest expression you've ever seen, but we can see where everything comes from because we started with the quadratic equation. We got our solution for delta t. We selected the positive solution, and now we're just substituting in this expression where v0y occurs, and we get this expression for delta t.